Hi everyone, my name is Damien Brady and today I'm going to be talking to you about DevOps best practices for Azure and VSTS. So I'm a cloud developer advocate at Microsoft and you can get hold of me if you want to contact me about this topic or anything to do with VSTS or Azure. My Twitter handle is DamoVisa and you can find me DamoVisa pretty much anywhere. My team at Microsoft is the team of League of Extraordinary Cloud DevOps Advocates and you can get hold of us on Twitter as well using that hashtag LOECDA, or have a look at our website to find out where we'll be and when. Now the larger group of cloud developer advocates, you can also contact us on Twitter and have a look at all of our profiles. There are a lot of developer advocates with a lot of different specialties, everything from Linux and open source to .NET and DevOps of course. Just have a look, there's a lot of us, and find out when we're going to be in your area as well. Now today, we're going to be talking about DevOps. So probably a good place to start is talking about what DevOps is. So at Microsoft, we define DevOps as the union of people, process, and products to enable continuous delivery of value to our end users. Now there's a lot of parts to this definition, but probably the most important ones are the fact that it's not just about products. So I'm going to be showing you Visual Studio Team Services, which is a Microsoft product. But if you just implement that in your organization, you're probably not going to have a lot of success. You really need the people and the process to be on board with this as well. If the people aren't bought into the idea of continuous delivery of value, or the process doesn't support that either, then you're not going to have a lot of success where you need it. And more importantly as well is that it's about continuous delivery of value. So value can be anything from bug fixes to new features, or even changes to infrastructure to make sure that you improve your availability for your end customers. So you want to do this continuously, deliver this value continuously, rather than every 3 months when there's a release cycle, or every 6 months. As soon as it's ready for the user, you want to make sure that you make it available. So with that in mind, you can also think about DevOps as kind of a 4-stage process and a bit of a cycle more than a left to right kind of process. Everything from the idea itself and your planning through to developing that implementation, testing it, releasing it out to production, and then monitoring what's happening in production as well to make sure that that feeds back into your planning cycle and that you can fix things that go wrong and introduce new features as soon as they're required. So that's really important as well. The next question really is, why is it important? And you can probably summarize this with one sentence, which is that your competition is already doing this. Even if you're an internal IT shop, if let's say you take a month to release a bug fix that took about 10 minutes to implement, during that month, you're probably going to be losing customers. If you have software directly to customers, they might move to a competitor. But even if your internal software, your team is suffering for that month while you're not implementing those features and fixing those bugs. So the practices of DevOps and doing it properly allow you to increase velocity and also reduce downtime. When there is a problem, it means that you can deploy a fix for that problem much quicker than you could otherwise. And then finally, it reduces human error. So point and click errors and copy paste errors and things like that become a thing of the past. Automation is very much a part of DevOps and this helps you actually deliver the value continuously and very quickly without so many errors that you might get if you're doing things manually. So Microsoft's solution for DevOps is Team Foundation Server or Visual Studio Team Services. Now these are actually the same product. They have exactly the same code base, except VSTS or Visual Studio Team Services is hosted for you on the cloud. We put this in Azure for you, and so you don't have to worry about the infrastructure. Whereas if you want to install it yourself, use Team Foundation Server and it's the same product. It consists of a whole number of features, but this is a new Microsoft. It's changed from the old days, and we're not forcing you to use the entire suite. If you're using like GitHub, for example, for your source control, you can absolutely continue to use that. If you're using TeamCity or Jenkins or something for your builds, Octopus Deploy or something like that for deployments, you can absolutely slot those in. And in most cases, VSTS will integrate really nicely with those products as well. So we're not forcing you to use the whole suite. Now, if you're deploying to Azure, of course, VSTS is kind of your no-brainer solution. It's the one you want to go with. The integration between VSTS and Azure is really incredible, and you'll see some examples of that in a second. Now, probably the best way to start with all of this is to actually show you how you can build a pipeline using VSTS, deploying your application all the way to Azure. So I have an application here, which is just an ASP.NET full framework application, and it's actually in source control already. We have this code in Visual Studio Team Services, but I haven't deployed it anywhere. So I'm going to try and deploy that to Azure. So let's jump over to the Azure portal, and I'm going to create a new website. So let's do that here. I'm going to call it Demo Tech Summit. Demo is already gone, that's great. I'm going to use my CDA subscription. I'm going to create a new resource group. I could deploy this to Linux as well. It's an ASP.NET full framework application, so that doesn't make sense. We're going to put it on Windows instead. I'm going to create a new app service plan. The app service plan is really just how much you pay for your application, how much availability is there for you. I'm going to leave Application Insights off. We will look at that a little bit later, but for a brand new application, there's probably not going to be a lot of data. So let's create that web application, and this should only take a few seconds, and then we'll be able to talk about how to deploy our application to Azure. So one of the ways that people might deploy is back in Visual Studio. If you go to your Solution Explorer, right-click on your application and go to Publish. Now, if you've ever heard me speak about anything, and this is something I really like to say, friends don't let friends right-click publish, all right? This is fantastic for trying things out, but as soon as you're working in a team with a couple of people, you probably don't want to do this because so much depends on your own machine and your own setup when you do this publish. And if you're pushing straight to production from your local machine, if the tests haven't run properly, or let's say your environment looks slightly different than the production environment, then this is a very dangerous thing to do. You can bring production down and impact all of your customers. So we don't want to do that. Let's jump back to the portal and have a look at some of the options we have. So let's go to our website here. And we can see right away we get access to this URL. So this is our web application running in Azure right now. We'll see we get our start page, nothing deployed to it yet. So some options for deploying, if we look back in the portal, we could have a look at the FTP site. So we could actually copy things straight up to FTP. Again, a little bit dangerous because if you deploy something bad, production is down. We'll have a look at the deployment options section here to see what other options there are. We can deploy straight from our source code as well. So let's just set that up quickly. And we've got our code in Visual Studio Team Services, but if you saw, there's a whole lot of other options. GitHub, Bitbucket, even Dropbox and OneDrive, if you have your source code there. Now ours is in Visual Studio Team Services. It's in this account. We just need to choose a project, and we've got our ASP.NET full application. We're going to use the master branch, and I'm not going to worry about performance tests for the moment. So let's set that up. Now what this is doing in the background is it's configuring a connection between Visual Studio Team Services source code, the master branch, and Azure itself. And there's a really cool tool that's available to you through Azure with websites called Kudu. You can get to that if we jump back to our actual application. If we zoom into here, if you just before Azure Websites.net type .scm, this gives you access to the management portal for Kudu. Now what Kudu does, amongst other things, is it lets you put your source code straight up onto the website, and then it will run deployment scripts. Now by default, it'll detect what application type you have. So it will have found that I have an ASP.NET full framework web application, and it will have done a deployment to make sure that that gets compiled and actually runs. We can see in here there's a whole bunch of JSON. This is just the details of the deployment. So we can see all of the stuff that's going on in Kudu. One of the things which is going on, we've got complete equals false, which means that the deployment's still in progress. Kudu lets you do some really cool things like have a look at a PowerShell or command line prompt and actually navigate through the folders that are there on your website as well. We only care about the deployments at the moment, so let's jump back and see what that looks like. We can see that a deployment has completed now, so we can drill in and see exactly what steps have been run. We can see it generating the deployment script, running the deployment command, and if we wanted to, we could have a look at those logs. But once again, there's a bit of a problem with this. Even if the deployment has succeeded, in this case, this is coming straight from your source code. There's no real opportunity to test this before you go out to production unless you have multiple of these set up for different websites. So if I checked in code or if I committed code to my master branch that broke the build, then production would be broken. And we really don't want that. So I'm going to disconnect this Kudu Git sync here, and we're going to replace this with something a little bit better, which is this continuous delivery section here. So let's go into this and we'll have a look at what this does. It'll tell us the steps that it's going to take when we continue, which is basically creating a build, test, and deployment, deploying to a test environment if we want, and then approvals for production and all sorts of stuff that we didn't get with our Git sync. So let's configure this. And once again, we need to tell it where our source code lives. We're choosing Visual Studio Team Services, but again, we could use GitHub or an external or internal Git. I want to choose my Team Services account, which is Demo MS Demos. It's chosen the project and the repository for me by default, and we're looking at the master branch. So this is where the source code is. We also need to tell it what it's building. Now, because we're building up an entire continuous build and continuous integration build and a continuous deployment, it needs to know what kind of build to create. Unlike Kudu, it's not going to detect this automatically. So we have to tell it what kind of application. We have a few options here. ASP.NET is the one we're using, but it could be Node, PHP, Python, or even a static web app if we don't need to do any compilation. Now we're ASP.NET, so let's choose that. I'm going to leave the load testing and configure deployment steps alone for the moment. These are valuable, but we're just going to use the default for the time being. So let's click on OK. I'm going to explain a little bit about what's happening here. Now, our code lives in Visual Studio Team Services, and that's fine. It could live in GitHub or in a local repository, but we need to run through a couple of steps to get this out to Azure. Now, the first one is to build our application every time there's a change to that master branch. The second one is to take the output of that build and then release that to a website. We have a lot of control over where that goes, but what's happening now is Azure is actually talking to Visual Studio Team Services to configure a build and then configure a release so that everything's set up for me so this just happens. Now, out of the box, this is quite similar to the Kudu one. It works in VSTS rather than in Kudu, so we have a bit more control over it. But out of the box, it's really just picking up every change to the source code, building it, and then deploying it. One advantage out of the box is that if the build fails, it won't try to deploy it, which is a bit of an advantage right away. So this is completed. Let's jump into the build definition to have a look at what it's actually created for us. And you can see there's actually a build in progress already. Before we jump into that, let's just go to the edit page and have a look at what it's created for us. So right out of the box, we can see it's doing a NuGet restore, building our solution. It's running tests, which is something Kudu didn't give us, and then publishing symbols and publishing that artifact back up to VSTS to be used later on. Now, like I said, we have full control over what happens here. So one thing I'm going to change the agent that actually gets used to build this. Out of the box, you get access to the hosted Visual Studio 2017 build, or a Linux preview, or even Mac these days if you want as well. Or you can use your own private queue. So I'm going to choose that one just because I've got a pretty powerful machine behind the scenes that can build these things a little bit faster. And if I wanted to get my code from a different location, I have access to GitHub, even Subversion, Bitbucket, or an external Git repository. These are options available to me as well. And if I wanted to modify this build, I could change the settings in the existing steps, or I could add new tasks. And there's a ton of stuff here. So .NET Core, Android, Ant, Docker, even Go now, Gradle, Grunt. There's a whole ton of tasks that are out of the box. And there's also marketplace tasks as well. If you want to do something that's not in the box here, you can download well over 500 different tasks from the marketplace to add to your project. That's all I need to change at the moment. So let's just save that change to the build. And we'll have a look at how we're going with that actual build itself. It's still in progress. So I can jump into that build and we have a look at what it's doing. And we've gone past the NuGet restore, building the solution, running our tests. And you can see on the right, we get full access to everything that's happening on the command line. So nothing is hidden from you here at all. If we drill into the summary of this build now, we can see our tests have passed, which is good because it's a brand new project. And we can even see down here, there'll be a link to the deployment in a second. Let's just refresh that and have a look. And down the bottom, here's the link to the deployment that's happening, and we're already deploying to what's named our production environment. On the left, we can see all of the associated changes. So because this was a project that I've played with a little bit, we've got all of the changes for this first build. We'll jump into the release and have a look at what that looks like as well. So this is the continuous deployment release that was set up as part of that Azure step, the Azure UI that we looked at. Once again, we get all of the console output if we want it, and we can see that it's actually deploying this Azure App Service right now. Let's once again jump into the edit screen for this release definition to see what it's done. And we can see that we're picking up the drop from that build definition, and there's a continuous deployment trigger on this as well, which means that every single time there is a new drop from that build, we will trigger this deployment to what's called our production environment. We also have the option of doing pre-deployment conditions, which I'll get to in a minute, or post-deployment conditions as well. So we have a bit more control there. If we look at what's actually happening in that production environment, there's one step, which is just deploying to an Azure App Service, which will deploy our website. So this is quite simple at the moment, but you'll notice that the connectivity between Azure and VSTS is all done for me. I don't need to set up any service principals and things like that. That's handled for me. So let's have a look at this release and see if we've completed, and we can see, yes, there's a tick. We can jump back to our website and just verify that that's been completed, and that will spin up a little bit for the first time because this is an ASP.NET full framework application. It takes a few seconds to spin up. And we can see there's our ASP.NET web application deployed through VSTS all the way to Azure. Now this is great. But you'll notice there's a couple of things we've looked at. There's a few different options that we've had for deploying our web application. So this is great. We've actually set up an entire CI/CD pipeline here for Visual Studio deploying to Azure. Now the key things I want you to note here are that this is available for any language and any platform. Sure, I'm doing an ASP.NET full framework application right now, but if I wanted to do PHP or Python or even build an iOS application and deploy to devices in my organization, all of these are available to me using that build definition. We saw how many tasks were available, and they kind of let you do anything on Linux or on Windows. The other thing I want you to notice is there's kind of a spectrum of good to bad when it comes to deployments. So the bad stuff, or the things that I wouldn't recommend, obviously right-click publish, but also things like copying and pasting to production, or even a manual push to a remote Git repository, which is one of the other options you have with Azure, or manual FTP uploads. These are a little bit dangerous because you're writing directly onto production, and so much depends on what you're actually putting in there. You don't get an opportunity to test very much. And it's a manual process, which slows things down. Slightly better is this idea of syncing from Git and letting Kudu do our deployment. But again, if I've introduced bad code, that deployment is not going to work and the site is going to be down in the meantime. What we really want to do is build an entire CI/CD pipeline with Visual Studio Team Services to get all the way out to production. Now, there are still some challenges with this. It's not smooth sailing, and you'll probably have picked up a couple of these in the kind of hello world that we've done. I'm going to look at a few. In particular, approvals, or an approval process to make sure not everything goes all the way through to production unless we're really happy with it. There's also the idea of downtime. Now we saw when we deployed that application the first time we hit it, there was a bit of a spin-up time for ASP.NET. We don't want to do this in a production environment. We want it to be available straight away. So we'll look at that. And then finally, the one I want to talk about is monitoring, just to close that loop when it comes to actually deploying our application, having a look at what's happening with it, and then pushing out to production as well, to let us feed back into what happens, what we're going to do next, the work that we're going to do. That's really important too. So let's attack this straight away. Let's talk about approvals to start off with. Now, there's a couple of ways that we can look at this. Number one is we probably don't want to do our deployment all the way through to production without checking that it works in a test environment first. But even better than that, we probably want to stop any bad code from even getting to that deployment stage or even the build stage. And we can do that with Visual Studio Team Services. So let's jump into our code section, and I'm going to go to the branches part of code here. And we'll see that at the moment we've only got a master branch. And that's okay, but it's a good practice to do changes through a pull request process. Now we can enable that. That's enabled straight away. You don't have to set anything up to do pull requests. But one of the really good features of VSTS is branch policies. So if we jump into branch policies, we can see that we can protect this master branch in a number of ways. I'm going to enable a few of these branch policies. So I'm going to require a minimum number of reviewers. It's just me in this team, so I'm just going to say one reviewer. And I'm also going to check this checkbox, which you should probably never check, which is allow me to approve my own changes, which is probably a bad idea in general. But for the purposes of demo, we'll do that. You can also make sure that work items are linked so people aren't doing work without the actual tasks behind them, which is a good idea. The other one I'm going to check is checking for comment resolution. So when somebody reviews my code, I have to mark those comments that they make as resolved to make sure that VSTS knows that I've read the message and I've understood it and made any changes that are required. And then finally, the one I'm going to point out but not enable is build validation. Now this is incredibly powerful. What this lets you do is before anything can be merged back into master, it'll have to pass a build. So I could choose a build definition that will compile my application, run tests, do all sorts of stuff like that. And only if those pass will it allow me to merge my changes back into master. Now this is a really kind of practical example of the idea of shift left, which is a DevOps principle. Shift left basically means that you move the discovery of any problems and the fixing of any problems as far left in this process as possible, if you're thinking about it as a left to right process. So as far left as possible is a really good way of making sure that you're picking things up when it's the cheapest to fix them. So by making sure that you build before you even merge that code into your master branch, you can make sure that no broken code is ever going to get compiled and pushed to production. So let's save those changes. So now our master branch is a little bit more protected. The other thing I want to do is change our release process. So right now, we're deploying directly to our production environment, as you can see when we go into the edit page. I don't want to do this. I want to go to a test site first. So let's just change this and make it dev. And then my production environment is probably going to look the same. So I can clone this phase or this environment to make sure that we're doing the same deployment to our production environment. So let's call this one production. So let's save that. And what I'd probably end up doing here is change this task to point to a different location so that dev and production are pointing at different websites. But there's another option available to me as well, which actually ties really well into the next problem that we have, which is the idea of reducing downtime. So when we deploy our application to production, as much as possible, we don't want to impact people who are using the application right now. So we want to reduce this downtime to 0, and we can actually do that with some really cool features in Azure. So let's jump back into that portal, and we'll have a look at our website here, and I'm going to click on deployment slots. Now, deployment slots are basically an extra website that you get access to. I'm going to create a staging slot here, which is pretty common practice. It's basically a new copy of our website, and it allows us to deploy to that other copy and then just swap these slots when it's up and running and when we know it works. The advantage here is that we are spinning something up ahead of time and then just changing the DNS details so that instead of hitting production, it's now going to hit what was staging. So we're basically swapping those environments. To get to our staging site, we can, if we zoom into the URL, type -staging or the name of our slot, and you'll see that we have a brand new website up and running. There's nothing deployed to it yet. All right, so we're going to change our release definition to enable us to actually use these slots. So if we jump back to our editing our release definition, I'm going to change my dev phase and change the task here to deploy to our staging slot. There's a handy checkbox there. I can choose the slot that I have, which is staging. And I'm going to add one more task here, which is basically going to spin up our application ahead of time so that we don't have to wait for it when it actually gets deployed. Now, this is actually a task from the marketplace as well. So this is a community-driven task. It's not one that was out of the box. But I can do a couple of things here. In my deploy Azure App Service, I can choose an App Service URL variable name. So I'm going to call this web URL, and I'll copy that. And in my smoke test, it's asking for a URL to hit. So I'm going to use that URL from the previous step, which means that if I change the name of my app service or the name of my website, it's still going to flow through to that next step. So my dev site now, or my dev environment in my release definition, will deploy to my staging slot and then spin that staging slot up and make sure that it's actually returning HTTP 200, that it's up and running. If we go to production, I don't really need to deploy anymore. What I need to do is swap those slots. So let's remove this task, and I'm going to add a new task. If I search for swap, I get this Azure App Service Manage, which is the slot swap, as well as a few other things with Azure App Services. So let's jump in here. We'll choose the subscription that we've got, which is the service principal that was set up by Azure right at the start. And I want to swap slots for this app service that I've got, which is Demo Tech Summit. I need to choose the resource group as well. That's going to be the same name. And then I need to choose where this swap is coming from. So it's coming from my staging slot, and it's swapping with production. And that's all I need to do. So right now, as things stand, I have a check and a protection on my master branch, so I can't actually make a change without submitting a pull request and making sure that those policies are met. And then even when the build and deployment works, it'll go to my staging slot and then it'll swap into production. There's one more thing that I want to do, which is to stop that from going to production until I'm ready. So if we jump into these pre-deployment conditions, we can set a pre-deployment condition for pre-deployment approvals. So what I'm going to say is that I need to approve this deployment to production. It'll go to dev automatically, but I have to say, okay, we're ready for production now. Once again, I'm going to change something that you probably shouldn't change, which is requesting that the user requesting a release or deployment should not approve it. I'm requesting it, I need to approve it because I'm the only person on this team. So that's going to make sure that I have a chance to verify that everything's okay before going to production. If you wanted to do this automatically, there's a new feature called deployment gates, which allows you to do things like run an Azure function to make sure that it's returning the correct things before you promote to production. You can even have a look at work items to make sure that no automatic bugs have been raised as a result of going to your staging environment. This can be really handy for canary deployments as well. So if you're deploying to a small group of users, if you get work items or an Azure function or something like that that verifies that those canary users are actually successful and using the application correctly, and then after a period of time automatically deploy to production, that's a really good way of doing it with these gates. Now I'm going to disable that for the moment and just stick with pre-deployment approvals. We'll save that. And then I'm going to go and make a change to my application, and we'll see this approval process and the zero downtime stuff working for us. So let's make a really simple change. We'll change the title here, ASP.NET with approvals and no downtime. We'll save that. And I'll try and commit this directly to my master branch. So we'll say new title, we'll commit and push. And you should be able to see right away we get an error when we try to push it saying failed to push to the remote repository. And then we can have a look at the output window for more details. We can see that it rejected that push to master because pushes to this branch are not permitted. We have to use a pull request. So let's do that. We'll jump back and we'll go to our branches. And I'm going to create a new branch, which is, I'm going to call it DA Brady, which is my handle. And I'm going to call it new title. So let's create that branch and we'll check it out automatically. So now our change belongs to that branch. And I'll push that branch up to the server. So let's push this branch back up to VSTS. What will happen here, which is really cool tooling in Visual Studio, is it'll actually prompt me to create a pull request. It's realized that I'm doing this in a different branch now. Maybe I want to merge that back into master. So we could click on that and it will create a new pull request, or we could jump back into our Visual Studio Team Services instance, go to pull request in code, and it's prompting me to create a new pull request directly from here. So I can do that. Let's create that pull request. We'll call it new title and create that. And we can see right away that we have this branch policies that we set up. It's already there running and making sure that we've got all of the policies met before we can deploy to production. Right now, we haven't approved it, but we've got all the comments resolved because there are none. But if I add a comment and just say this is not good, we'll see that that policy is no longer met. I have to mark that as resolved before it comes back and says that this is okay. If I wanted to approve it, then I'd be able to merge that, but I'm going to set up an autocomplete. So as soon as these policies are met, it will auto-merge. I'm going to check that checkbox to delete the branch because I don't need it anymore after the pull request. I could squash those changes if I wanted to as well. Well, let's just set this as the default. And then when I approve this, you'll see that it will automatically close that pull request, merge it back into master, and finish that process for it. If I was using a bit more complex branching strategy, I might want to cherry pick that into a different branch, maybe a release branch or something like that, or revert that change if I really want to. Now, the other cool thing is because we've got a continuous integration build on our master branch, we should have already kicked off a build after that pull request has run. And sure enough, we can see that there is a build in progress. Let's drill into that build and follow it through. And we can see that it's already done our NuGet restore, it's building our solution, it's running our tests, and it's published the artifact. So that build has succeeded already. Once again, if we jump into the summary of this, we should be able to see the deployments if we refresh. So here's our deployment running, and we can see there's two environments now at the moment. So our dev release is queued to our dev environment. And once again, we can see all of the different things that happen there. Once again, we get the entire build, the process that's happening on our hosted agent. And I can refresh this if I want details more quickly, but all we're really doing here is downloading that artifact and then pushing that up. So if we jump into our actual application here, this is our staging application. We should see this one light up when it's completed. So here we go. We've got our release. It's deploying the Azure App Service. And we can see all the details on the right. And then when it completes, we should be able to see our staging site up to date. So we're quickly running our smoke test, which means that we'll hit the application, and then once it gets an HTTP 200, which means that ASP.NET has spun up for the first time, it'll be ready to go in our staging site. Let's just refresh this to see if we've got more details here. Smoke test is still running, but that will finish any second. And in our staging site, we can refresh this and we can see that we've got our new change. ASP.NET with approvals and no downtime. Now the cool thing here is that this is the staging site, but we've stopped short of going to production. And in fact, production is still running with everything that was there before. And if we go back to our release, it's stopped ahead of time to say there's a release for our production environment that's pending. So this is stopped at my pre-deployment approvals. If I approve this, then we'll see this start to deploy to production. Now remember, we're not actually moving anything to production here. All we're doing is really swapping those slots over. And you can see in our Azure portal again, if we jump in our continuous delivery page, we can see not just that first thing where it's set up the continuous delivery and triggered the build, but we can see what's actually running in production right now. We ran release 9 into production. We're actually running one at the moment, you can see, so we get this traceability right from Azure as well. Back in our web application, if we just start refreshing this and like visiting the pages around just to demonstrate that this is still available to us, We have our web application with the old code in it, but it's swapping that slot at the moment, and at some point, we'll just get this switch over between staging and production. So it's still responding. We're still getting our old site because that switch is still happening. But at some point in a couple of seconds, we should be able to get our new application. And you can see there was no actual downtime. The site was responding constantly, but just at one point we swapped over to our other application, which is really cool. We've lost that whole problem with production downtime while we do a deployment. Now, there was one more issue that we were going to address, which is monitoring. Now, because I just created a brand new web application, this is probably not going to be very interesting. There's not going to be a lot of traceability apart from my clicking around just then. So let's look at an application that's already been set up with Azure and with Application Insights. And that's the Smart Hotel application. We'll go to that homepage and we should be able to see this is our hotel website. If you were watching Connect or one of those events, you would have seen this come up. And one of the features of Smart Hotel is the ability to upload a picture of a pet and see that, or find out whether that pet is able to accompany you. So let's go to our images. I'm going to upload my picture of a dog. And it's going to upload that image to Azure. It's going to analyze it to find out what kind of animal it is. And then it's going to process it and tell me whether that dog can arrive in my hotel. And it looks like a dog and it's accepted. I can bring my dog with me. But if I choose a cat, it's going to upload that image. It's going to analyze it, find out that it's a cat, and tell me that I'm not allowed to bring my cat in. Now, personally, I think that's a bit of a bug. We should really be accepting pets of all shapes and sizes. This is a personal opinion, but because I'm able to add these bugs and things, I can do that. Now, Smart Hotel is also in Visual Studio Team Services. And if we have a look at my dashboard for Smart Hotel, we should be able to see that I currently have no tasks assigned to me. There's nothing here. What I would really want to happen is, as a result of that request to go and get a cat, I want to tie this back into a new task in Visual Studio Team Services. And so I can do that if I jump into my Application Insights portal for my Smart Hotel site. I should be able to see all of the different requests and things that have happened while I've been visiting that site. Everything's traced for me, and I can feed that stuff back into Visual Studio Team Services to close that loop we were talking about before. So let's drill into all of these server requests. And we should be able to find my requests. There we go, pets get upload state. I just happen to know that that is the URL that gets that information. So this is probably a good context for a developer who wants to fix that bug. We can see all of the requests and things like that. Let's drill into this one, which looks like the most recent. And I can see exactly what was happening at the time. So we can see the actual request, the response, how long it took. We can even see all of the remote dependencies. So we can see 3 calls to Cosmos DB here. So we can actually drill really, really deeply into what happened as a result of this request. Now, there was a problem with this. This is a really good context for the developer. So I'm going to add a new work item. Now, this is linked back to VSTS. We're closing this loop here. I'm going to say cats should be allowed. And I'm going to assign this to me. And again, we can see all these details. We can add anything else to this if we want, or just click OK and let that create a new work item. Back over in my dashboard in Visual Studio Team Services, if I refresh this, I should be able to see I now have a task assigned to me. It's a bug saying cats should be allowed. I can drill in and go down to my repro steps, which have already been created for me. And even right at the bottom, I get this deep link back into that page that I was at before, showing me all the details of what has happened. So as a developer, I have a huge amount of information that can help me fix this bug. We've closed that loop between what's happening in production and gone all the way back to planning and to fixing bugs, which is really, really powerful. So we've looked at these 3 challenges that we have: approvals, downtime, and monitoring. And you can solve these in a number of ways. Approvals you can solve with branch policies to make sure that pull requests get submitted and things don't go straight to production. pre- and post-deployment approvals to make sure, in my case, that I checked and said this is okay to go to production. Or if you want to do that automatically, you can do it with deployment gates. We reduced our downtime by using deployment slots, deploying to a staging slot, then swapping. And we looked at monitoring with Application Insights, which can feed all the way back into Visual Studio Team Services to close that loop and actually feed our production metrics back into our planning phase. Now, if we have a look at DevOps as our cycle, planning can come from our tasks that we've decided on ahead of time, but also from our monitoring and our production metrics. Our development is a little bit smoother, and we can make sure that we can approve changes before they get to production into a release. Our release is a little bit nicer as well because we don't have downtime in production when we deploy. And once again, we're monitoring everything that happens in production to feed back into that planning phase as well. When you're actually doing the deployment, you want to make sure that you're going all the way to the right with this CI/CD pipeline. But you can go further than that, and you can do things like branch policies, pre- and post-deployment approvals, and gates, like we've seen. Use deployment slots to make sure that production has no downtime, and Application Insights to feed that information back again. So this is really where we want to be, and VSTS and Azure allow us to do this in a really nice way. So thanks everyone for joining us. I hope you enjoyed those demos and got something out of it. And feel free to contact me on Twitter if you have any questions.